Today we're going to take a look at a quadratic problem. The question says, determine the values of d such that half into x plus d all squared plus 2 into x plus d minus 5 is equal to x plus d plus 3 will have one positive and one negative root. Now, there's a lot of terminologies here, a lot of new words. Let's break it down. So let's first start with roots. Now, what are roots? When we deal with a quadratic function will have x-intercepts. For example, if I have a function and that function is y is equal to x squared minus 1, then the roots of this function are going to be the x-intercepts, which are going to be 1 and negative 1. Now, there are cases where there won't be x-intercepts, but that's a discussion for another time. The thing we need to understand here is that the roots are the x-intercepts. So now that we understand what roots mean, let's take a look at what the question was asking for. The question was asking for a positive root and a negative root. Now, what does that imply? So a positive root and a negative root simply means that the function we are dealing with should cut the x-axis on the right-hand side, so a positive value, and the x-axis on the negative side, a negative value. For example, if I have a function like this function is said to have a positive root and a negative root because it's going to have an x-intercept that is positive, say 3, and it's going to have another x-intercept or another root that is negative, say negative 3. So how do we now tie this in to help us answer the question? There's one more piece of information that we need to look at before we actually start solving the question. And that is, if a function has one positive root and one negative root, the product of the roots are going to be negative. So in this case, 3, let's write it here, 3 times negative 3 is equal to negative 9. The product of the roots are going to be negative. If we have a positive and a negative root, we can make the conclusion that the products are negative. So say, for example, we have the roots of a function. And let's say the roots are x is equal to, let's go with 5 minus k. That's x1, so the root 1. And let's do x2 is equal to, let's go minus 1 minus k. So if these are the roots of this function, whatever this function is, or we can say the x-intercepts of the function, to calculate the values for k, we need to set that the product of these roots are going to be negative. So we can say that 5 minus k multiplied by minus 1 minus k is going to be negative. Now it's a matter of solving like how we would solve a normal inequality. The easiest way is simply to test. So substitute a value for k in and then test to see if it's going to give us a positive value or a negative value. But the more traditional way would be to solve critical values. Let's solve for the critical values. So first we will say that 5 minus k is equal to 0. That means 5 is equal to k. The other critical value, so this is critical value 1. The other one will be minus 1 minus k is equal to 0. So that means that minus 1 is equal to k. So now that we have our two critical values, we can set these on a number line. We have 5 on one end, We have negative 1 there. Now when we test, all we need to do is substitute a value in. Let's substitute 0. 0 lies somewhere here. So if I substitute 0, I'm going to have 5 minus 0 multiplied by minus 1 minus 0. 5 minus 0 is 5 times minus 1 minus 0 is minus 1. So 5 times negative 1 is negative 5. This is a negative value. So it means that in this region between minus 1 and 5, we are going to have a negative, negative values. That means here we're going to have positive values, and here we're going to have positive values. So if we are looking for where the roots are going to be negative, one negative and one positive, the answer here would be is that k will be between minus 1 and 5. Now let's go to our question. So our question says, determine the values of d such that half x plus d all squared plus 2 into x plus d minus 5 is equal to minus x plus d plus 3. So it will have one positive and one negative root. The first thing I would do is I would try and replace this bracket. So I would replace this, since it's the same thing. Let's replace it with p. So that's p, that's p, that's p. So I will have half p squared plus 2p minus 5 is equal to minus p plus 3. Let's transpose and write it in standard form. Half p squared plus 3p minus 8 is equal to 0. So standard form now, we multiply by 2. We'll get p squared plus 6p minus 16 is equal to 0. We can now factorize. We'll get p plus 8 and p minus 2 is equal to 0. That means p is equal to negative 8 or p is equal to 2. Now we can substitute back what we originally took away. So we can say that x plus d is equal to negative 8 or x plus d is equal to 2. Now we want to write it in terms of x. So we'll simply have x is equal to negative 8 minus d, or x is equal to 2 minus d. Now these are my roots. These are the roots. So if we are looking for one positive and one negative root, simply root 1 multiplied by root 2 must be less than 0. So we can say minus 8 minus d multiplied by 2 minus d is less than 0. Now let's get critical values. The critical values here, minus 8 minus d is equal to 0, minus 8 is equal to d. That's critical value 1. Here, 2 minus d is equal to 0, 2 is equal to d. That's critical value 2. Let's draw in our number line. We'll have negative 8 here, we'll have 2, and now let's test. Again, let's test 0, since 0 is between them. Minus 8 minus 0 is minus 8, and then 2 minus 0 is 2. Negative 8 times 2 is negative 16. So this region in between here is negative. That means that's positive and that's positive. Since we are looking for where it's going to be negative, the answer now is going to be simply that d must be between negative 8 and 2. Thanks so much for watching. If you found this useful, don't forget to like, share, and subscribe for more videos. I'll see you in the next one. Bye-bye.